For our mini project, we did a single stage 45 nm technology operational amplifier. It consists of 6 transistors, 2 PMOS and 4 NMOS transistors. The basic current mirror is built of 2 NMOS circuits. It is to maintain the current stability in the circuit. The remaining circuit, called a differential amplifier, it contains 2 legs as 2 input. M3 interfered input applied across to the input-output signal. If any signal applied to the second leg of the differential amplifier, then it will produce as comparator output, adder or subtract.
Project methodology. We start by discussing the design idea and select on a design. Next, we prepare the design specification and we move on with circuit drawing using mental graphics software. After that, we add the parameters to each of the components available in it and we simulate the circuit. And next, we do a comparison between the obtained result and our design specification. If we meet that specification, then we will analyze the report, the results, and will end, or else we will continue again from the circuit drawing until the comparison and the simulation. Design specification. DC open loop is more than 73 dB. Where the current is in open loop, it has no control over output value. Unity gain bandwidth is 5 MHz, where it is the frequency of the input signal. Phase margin is the amount of change in open loop phase needed to make a closed loop system unstable, and we use more than 60 degrees. The CMRR used is 80 dB, more than 80 dB. It's the ability of device to reject common mode signals. Power dissipation or loss of power is less than 2 microwatts. Slew rate, or also known as the maximum rate of change of an op-amp Vout, is more than 10 volts per picosecond. The load capacitance is 10 picofarad. It is the amount of external circuit capacitance in parallel with the crystal itself. Load resistance is the cumulative resistance of a circuit, and it is 1 kilo ohm. Load voltage is the drop voltage when going from the no load to full load condition on a power source, and it is plus minus 1.1 volt.
Hi, my name is Omar Rizwan. I want to present about the DC analysis of one-stage amplifier circuit. As you can see in the circuit, the VDD consists of resistor with the value of 100 kilo ohm and it's got an external voltage source with 4 volt, and there is a capacitor with 11 picofarad at the output, and there is two input, non-inverse and non-inverse, with the voltage source of 4 volt. As you can refer to the waveform, there is a input inverse and non-inverse waveform with 130 megavolt, and also there's an output voltage with 225 volt. As we compare, when the output voltage of the circuit is amplified into the input voltage, it means that the circuit is increasing the amplitude of the input signal, making it stronger. DC analysis of a one-stage amplifier circuit is important because it provides more important information about the circuit's steady-state error, steady-state operating conditions. The DC operating point, also known as the quiescent point, is the point at which the circuit is in a stable state with no input signal applied. This point is determined by the DC voltages and currents in the circuit, and is a crucial factor in determining the overall performance of the circuit. Additionally, the DC analysis is important for determining the bias point of the transistors, which is the point at which the transistor is operating in its most linear region. It is also important to check the circuit for safe operation of the transistors. Transistor's safe operating area is the range of the operating point where the transistor can function without damage. When the DC analysis is done, it is important to ensure that the circuit is operating within the safe operating area of the transistor to prevent damage or retraction of the transistor. Thank you.
Hi, my name is Rudaman. I'm a member of Group B-6. I am going to present about the current measurements in our circuits. So, first of all, let's look at the circuit. In this, we could clearly see that our transistor that we used was NMOS and PMOS. Both the transistors that were used were depletion mode transistors. The current source for DC was added in our circuit. So, this is because we want to measure both the inverting and non-inverting inputs. When measuring, we have proven that both the values were inverted, which is for the non-inverting input and the inverting output. So The current flowing through a transistor can be used to determine its operating point and overall performance. Measuring the current allows the calculation of key parameters such as gain, power dissipation, and input-output impedance. Measuring the current can also be used to detect any potential problems or failure within the transistor. By creating this graph, we could find there is total 4 types of current in the transistor, which is body current, source current, gate current, and drain current. Body current in MOSFET is the current flowing through the body of the transistor, which is connected to the source of terminal internally. It is also known as a substrate current. Source current in a MOSFET is the current flowing into the source terminal, which is the input of the transistor. Gate current in a MOSFET is the current flowing into the gate terminal, which controls the flow of current through the channel between the source and drain terminals. Drain current in a MOSFET is the current flowing out of the drain terminal, which is the output transistor. With this, we could conclude that the body current is used to monitor the overall health of the MOSFET and to ensure there is no leakage current flowing through the substrate. This can indicate a potential problem such as a short circuit or a defect in a semiconductor material. The source, gate, and drain currents are used to determine the overall performance of the MOSFET, such as the gain and power dissipation. Thank you.
Hi, I'm going to present about transient analysis. So this is the circuit and graph of the single stage. The frequency response of 45 nm operational amplifier, which shows a DC gain in dB versus frequency in Hz, and phase margin of operation amplifier in open loop. The DC gain is found to be 39 dB and phase margin of 75 Celsius, which is good enough for an operation amplifier operating at high frequency. In conclusion, the single-stage operational amplifier was simulated in Mentor graphics software. After simulating the proposed circuit, a high gain of 39 dB has been got with several other good parameters like gain bandwidth of 5 mHz. The response of the circuit is very high. Hence, this proposed model can be applied in complex analog and mixed signal application. Thank you.
This is the calculation for the capacitor 11 picofarad for 70-degree phase margin. So this is how we calculated according to our specification. You can see we calculated for all the width and length for transistor M1 till M6 since we have 6 transistors. Thank you.